This will be for the con assignment, area of a sector. So a sector is a piece of the area of a circle. Okay, it's basically like a slice of pie or a slice of pizza. So I drew a circle here, and this area shaded in pink would be considered a sector. Okay, and the angle made within that sector, that's considered the central angle. Okay, and of course this dot in the middle is the center of the circle. So the central angle is represented by this Greek letter theta. So this ratio and proportion will always work for when dealing with area of a sector. Okay, so this is the central angle theta divided by 360 or 2 pi, and that equals the area of the sector divided by the area of the whole circle. Okay, so you want to use, in the denominator here, you want to use 360 when dealing with degrees, and you want to use 2 pi when dealing with radians. Okay, 2 pi, that's the same as 2 times pi. And A sub s, that represents the area of the sector. Okay, and capital A is the area of the whole circle. Remember, the formula for that is pi r squared. Okay, so our first problem, a sector with central angle of 4 pi over 5 in radians, has a radius of 5 centimeters. All right, so both of those are given on the diagram. This is the central angle, theta, that equals 4 pi over 5. And recall the radius, it goes from the center to the circle. The radius r is 5 centimeters, and they want us to find the area of the sector. Okay, so since we're dealing with radians, we want to use 2 pi, not 360. All right, so I'll get rid of the 360 for this one. Okay, so in place of theta, I'm going to write 4 pi over 5. And the denominator, I'm going to use 2 pi. The area of the sector is what we're solving for. And the area of the whole circle we need to solve for, and then plug that in for A right here. So recall we said the area of a circle is pi r squared. Okay, we're going to leave pi alone, so that's going to be pi times r squared. We said r was 5, so that's 5 squared. Okay, 5 times 5 is 25, and that's times pi. So I'm going to use 25 pi in place of A. So that goes right here. All right. And now in order to solve for AS, sector area, I'm going to multiply both sides by 25 pi, since I'm dividing by 25 pi right there. I'm going to multiply both sides by 25 pi. Okay, so on the right-hand side, 25 pi over 25 pi cancels, and the sector area equals this mess right here. So let's cancel some things, okay? 25 pi, if it helps you, it's the same as 25 pi over 1, okay? These fractions are multiplied, so pi divided by pi cancels, okay? And let me see. I just want to clean this up for you. This is going to be 25 times 4 pi over 5. And that whole thing is divided by 2. Okay, so if you want to make it 25 over 1 again, same thing. Okay, 25 on the top and bottom. 25 divided by 5 cancels. Okay, and 5 times 4 is 20 times pi. And that's divided by 2. And 20 divided by 2 is 10. That's 10 pi. Okay, so you could have done this on the calculator if you wanted to. 25 times 4 divided by 5, hit equals, and then divide it by 2. Okay, remember to leave pi alone and then just add it on at the end. So our answer is 10 pi. And since the radius was in centimeters, it got squared, and the area units are centimeters squared. All right, one thing I forgot to mention about this ratio and proportion here, this fraction here on the left is for the angles. Okay, so the central angle theta, that's just a piece of the whole circle, okay? It doesn't go all the way around. But if you went all the way around the circle and measured the angle, it would be 360 degrees or 2 pi radians. So the piece is in the numerator and the whole thing is in the denominator. Same thing with the area, okay? The area of the sector is just a piece of the circle, whereas the area, capital A, is the area of the whole circle. So that's why this works, because the more this central angle opens up, the more area is going to be covered. So here we have a sector with radius of 8 and an area of 56 pi. What is the central angle measure of the sector in radians? All right, so let's see here. They said they wanted the angle in radians, okay? So we're going to use 2 pi, not 360, all right? And basically the central angle is going to be this angle measurement right here. All right. So we don't know theta. That's what we're solving for. And we're dealing with radians, so we're going to use 2 pi. The area of the sector is given. This area in pink right here is 56 pi. And the area of the whole circle is pi r squared. That's going to be pi, and it says r radius is 8 centimeters, so that's 8 squared. Okay, 8 times 8 is 64 times pi. And we're going to leave pi alone. All right, so in place of A, I'm going to write 64 pi. All right. Solving for theta, here we're dividing by 2 pi. The opposite of dividing by 2 pi is multiplying both sides by 2 pi. All right, so 2 pi over 2 pi. And we're left with theta. Pi divided by pi cancels. Okay, 64 divided by 2 is 32. And we have 56 over 32 times pi. All right, so reducing that fraction, 56 divided by 8 is 7. 32 divided by 8 is 4. And we still have pi. So that's it. The central angle in radians. So we should have 7/4 pi as an answer. 7 pi over 4. Okay, when pi is in the numerator, or when pi is out front, that's the same thing. Okay, a sector with radius 7 has an area of 49 over 3 times pi. And what is the central angle measure of the sector in degrees? All right, so once again, we're looking for the central angle measurement right here. Okay, and that is the Greek letter theta. All right, now they said they want it in degrees this time. So I'm going to use 360, not 2 pi. All right, so theta is what we're looking for. It's divided by 360. The area of the sector is given. The area of this right here is 49/3 pi. And the area of the whole circle, we know that is pi r squared. So that's pi times 7 squared. 7 times 7 is 49. And we still have the pi. So we're going to use 49 pi. We're going to use 49 pi in place of A. Okay, solving for theta, I'm going to multiply both sides by 360. All right, and on the left-hand side, it cancels. So pi over pi also cancels. And let me see here. 49/3 divided by 49. Okay, this is the same as 49/1. We can do keep, change, flip right here. So keep 49/3, change divide to multiply, and flip 49/1. And it's still times 360. So now it looks much better. Okay, see 49/49 just cancels. 360 divided by 3 is 120. And that's in degrees, okay? Remember, when the number's out front, it's the same thing as if it's in the numerator. You can put it over 1 if you want to. So 120 should be one of the answers. Answer C.